Hi, everyone. Welcome to the Climate Confident Podcast. My name is Tom Raftery, and with me on the show today, I have my special guest, Professor Valerie Thomas. Valerie, welcome to the podcast. Would you like to introduce yourself?
Thank you. Yes. As you said, I'm Valerie Thomas. I'm a professor at the Georgia Institute of Technology in Atlanta, Georgia, and I'm in industrial and systems engineering and in public policy.
Okay. Georgia Tech has got a great name in the tech space, doesn't it?
We agree that it has a great name. We've been ranked, the number one public university in energy. My school, industrial and systems engineering, is the top. So, yeah, we agree. Thank you.
Okay, no problem. And how did you get there? What's your road to being there now?
All right, my road has been long and winding. I have a PhD in theoretical physics. I studied grand unified theories and monopole, catalysis of proton decay. It was great. And then I decided to work on nuclear arms control. I did that for quite a few years. That
Wow.
was super great also. This was during the Gorbachev era,
Okay.
so I got to go to the Soviet Union and detect radiation from nuclear warheads. That
Wow.
was really terrific. Why would you do anything else? But I decided I wanted to work on energy and environment, and Georgia Tech made a place for me. And so that's what I've been doing for quite a while here.
Nice. Nice. And what kind of areas of study are you looking at the moment?
Okay, I do a big range because I look at energy systems, and then I also work with teams that are developing new technologies. And usually my job of that is figure out, okay, what are the greenhouse gas emissions and maybe other environmental impacts, and how much is it going to cost? So, one of the things I've been kind of really happy to work on is capturing carbon dioxide from the air and making fuel from it.
Right.
Um, I work on other things. I work on food waste, like, getting food that farmers haven't been able to sell and getting it to market. And, how much does that help? How much does it help? Working on helping the paper industry to be more energy efficient. It's one of the most energy consuming industries that we have. Hydrogen. How can we get hydrogen to power vehicles, trucks? Where do we get it? How do we make it? How do we make it cheap? How do we make it environmentally benign or at least reasonable?
Mhm.
So that's a few.
Okay. Let's dig into the carbon capture one because
Mhm.
that's what we talked about on the intro
Yep.
that we were going to talk about. Tell me a little bit about it. I mean, it sounds like a bit like sci-fi, and we've seen pictures of some of the facilities in Iceland, for example, where they are capturing carbon from the air. Can you break it down for us exactly what does it take to pull carbon dioxide out of the air, and why is it so challenging?
Yes. So on the one hand, it is not challenging. So you get, some kind of sticky material and you stick it out in the air and carbon dioxide sticks to it. You've captured carbon dioxide from the air. Okay. Now you want to keep doing this to get more carbon dioxide. So somehow you've got to scrape that carbon dioxide off.
Hmm.
That's harder, but we do this in the lab and demonstration plants. So we put it in a vacuum. What you've really got to do is now you just got to heat it up so that the carbon dioxide comes off and then you suck it out. And then it's all fresh and ready to get some more. So it's not hard. You do have to heat it up. That does take energy. We can do it. However, it's hard to get anywhere near as much as we're shooting out into the atmosphere. So it's got to be big, and that makes it expensive.
Yeah.
So that's why it's tough.
Yeah, because I was going to say, I think if I remember the numbers correctly, the Climeworks facility in Iceland is scaling up from 4,000 tons CO2 a year to 10,000. And 10,000 tons a year is nothing,
You. Yeah.
nothing, absolutely nothing.
Yeah.
We would want to be getting out of the atmosphere something like 10 billion tons a year, really, to make a significant difference.
Mm-hmm.
Even a billion
Mm-hmm.
tons a year would be good,
Would be nice. Yeah.
but 10,000 is nothing. So we're orders of magnitude off right now.
Right. So, absolutely. We're orders of magnitude off. Why is that? Well, okay, we haven't built a whole bunch of facilities to do this, but there are really good reasons not to do this right now. One, as I was saying before, it's expensive.
Hmm.
It's more expensive than a whole bunch of other, even sort of unpleasant things that you could do to reduce the amount of carbon dioxide in the atmosphere. And then, second, you get it. What are you going to do with the carbon dioxide? You should do something. So, these projects, like the one in Iceland, they're demonstrating and testing and trying to scale up, looking for ways to make it cheaper.
Mm. One of the reasons that it's important to try and capture carbon and take it out of the atmosphere is because there's so much of it there. And if we could flip a switch tomorrow and stop burning fossil fuels and emitting CO2 into the atmosphere, there would still be literally hundreds of billions of tons of excess CO2 in the atmosphere from the decades and decades and decades of us having put it up there. So getting it out, seems like a good idea, but the scale of the problem, how do we tackle that? I mean, you've mentioned it's expensive. It's not just expensive, it's also, it requires a lot of energy. So can it actually be done really at
Okay,
scale, at the scale we need to do it?
all right. Depends what you mean by can.
Can we
S-
afford to do
So,
it both
so
financially and energy wise?
So it makes no sense to say, oh, this is the solution to fossil fuel use. Let's just do this. We can do it. We can just capture it and put it away, dig a hole. So it's one of the most expensive options. People have done these integrated assessment models where they look at all the emissions we expect to be having and then all the ways you can reduce emissions from fossil fuels and other things. You can have electric vehicles, you can be more efficient in industry, you can manage your food system better. There are a lot of things. And working all the way down to try to not get the climate to change too much, you got some extra. And
Hmm.
so that's where people look at things like capturing carbon dioxide from the air. Even if we are in that situation of, we're just doing amazing stuff with, we sail our ships across the ocean rather than using diesel fuel like we do now. Still, will we build that much? I don't know. Now, yes, what could we do? There are other ways, there are lots of other ways that carbon dioxide comes out of the air. It does come out naturally, even if we do nothing. Over, a good 1,000 years or so, it's going to be absorbed in the ocean. And the ocean, got real acidic and so on because you have carbonic acid, but it gets absorbed in the ocean and it's in the top layer of the ocean. And over a really, really long time, it gets mixed into the deeper ocean. So the problem will handle itself eventually. The issue is we're talking thousands of years in the future. There may be other things that we do not want to have happen that will happen if we keep that carbon dioxide up in the air, even for 100 years.
Hmm.
So as a researcher, I'm not working on this because I'm advocating. Let's go do it. Let's go spend as much as we can and do it. It's more, okay, here this is. We can do it. What, can we be really smart or something and find a way that it's suddenly cheaper, much cheaper, or there are little side cases we can do, or niche applications, or saves a lot of energy, or there's something about it that people will love and want to buy it, even if it's expensive. We're just working it. So that's what we're doing.
Okay. And is it better to try and capture it from the air where it already is, but in very minuscule amounts, 420 something ppm, or from the flues, for example, of coal fired power plants or concrete kilns or metalworks or the paper mills you talked about earlier? I mean, it's in much higher concentration there, so it should be easier to capture there, right?
Yeah. So they're different cases and they're kind of interesting. So, yeah, if you can go at a coal plant, there's a lot of carbon dioxide coming out the stack. Just go and stick your vacuum nozzle in the end of that stack and suck up that carbon dioxide.
Mhm.
Absolutely. So it's right there and it's at higher concentrations. That does mean you need less energy to suck it out there and capture it and do your stuff. And that makes it cheaper also. So we've looked at that actually quite hard. We thought, okay, we're going to make biofuels. We're going to make biofuels from carbon dioxide. It's like a win-win situation. So we're going to put our biofuel plant down. Biofuel plants, they're great. They can be on concrete, they can be in the desert. But if you've got to put it next to a coal plant, you've got two problems. One, there might be other things next to the coal plant. They're not usually way out in the middle of nowhere. And then you have the risk the coal plant might shut down in a few years.
Indeed.
And it's such a risk for industry to build shiny new advanced technology to the old 50-year-old coal plant that, people are out there picketing saying we should shut it down. So it's great to get it from a coal plant, something like that. The advantage of getting it from the air is you can go to a miserable place and because the air is all the same, and you put your facility there, it can bring some economic benefit. And then the other thing is, yeah, it's much less concentrated in the air,
Indeed.
but it's like 100 times less or even more than in that coal plant. So, but it's not 100 times more expensive. It's not 100 times more energy. You have to blow the air over your sticky stuff. And so the less concentrated it is, the more air you have to blow over it in order to get the stuff off. And so it makes the energy, it's like 3, 4 times more, which is much more than you want it to be, but it's not 100 times more. So it's possible that it's not completely crazy.
Okay. And you mentioned biofuel plants there. What's that about?
Okay. So you may have other episodes. Your listeners may know about biofuels. If you make a fuel using biomass somehow, and it's still got carbon in it, but it's carbon that the little plants captured from the air. So it's kind of capturing the air and then you burn it and release it. So it's, kind of very natural, not net zero, but very, kind of natural. It's going in the right direction. Okay. And a way, if we could get it to work really great and if we could make it cheaply, is grow something like bacteria or blue-green algae and use that to make your fuel. We have one kind that actually makes ethanol on its own. It just makes it and it floats out into the water and we collect it and there we have it. But these things, you're growing them out in the sun in big plastic bags.
Indeed.
They need their little plants, kind of algae bacteria. They need carbon dioxide to grow. And it's just not enough to just have your pool of water with the air. You need to pump in carbon dioxide. So the idea is, okay, we can get carbon dioxide from a coal plant, or we can just capture it from the air and put it in these concentrators and get it to the plants. So the multiple wonderful things if this would all be really cheap. One is you'd be making fuel. So you'd have something to do with the carbon dioxide that you've captured and you can sell it for a profit. And, maybe even sort of transition away from things like gasoline. So you're doing something with the carbon dioxide. You're doing it out there in some miserable, hazardous waste site. So it's great. A fun thing that we worked on is, okay, we're going to do this and we're going to see if we can do it. And also, what we looked at, we're trying to make everything cheaper. So you need energy to capture carbon dioxide from the air and pop it off of there, but you also need energy to make your biofuel.
Right.
And there's, waste heat and stuff. So can we kind of put these together and they share their waste heat and share the energy so that it's kind of like a combined heat and power system, except it's combined carbon dioxide and fuel system. Can we do that? Use less energy and then have less cost. And so, end of the story is yes. But getting there is thing is, these are algae. These are blue-green algae.
Mhm.
They're living beings. So they're just doing their thing in the daytime. And in the night, basically, they're sleeping.
Right.
So they don't want any carbon dioxide at the night. They want just carbon dioxide in the day.
Mhm.
But then we, at least in our model, and in fact, we've built this huge thing to capture carbon dioxide from the air, and it's really expensive. Do we want to shut it down at night and wait for the algae to wake up and then turn it back on, and have this sort of circadian rhythm? Or do we want to keep this big carbon capture going day and night? And then you got your carbon dioxide, and then you're going to store the carbon dioxide by refrigerating it overnight. And then you don't have to build as much capacity to make your biofuel plant. So we looked at this up, down, and sideways. It's sort of some of the stuff I do of, designing it different ways, testing out the cost, testing out, well, how much energy do we need to store the carbon dioxide? And so, well, our answer for our system was, yeah, you should build your big carbon capture, store it, and then you just feed it to the blue-green algae when they wake up and they're ready for it. So
Okay.
it's kind of fun, interesting, kind of a braided procedure that we invented.
Nice. And the biofuel that comes off that is usable by any vehicle, I want to think, or industrial process that would normally use petrol or diesel or similar, no?
Different biofuels. People get the idea there's biofuel and
Mm.
it's a thing, and then you protest against it, and it's made from corn. So there are different biofuels. One prominent biofuel is ethanol. Ethanol, we can drink it. It's a safe, and one way to make it is from corn. We do that in the US. One way to make it is from molasses, and they do that great in Brazil. And however, you don't have to use food stuff. You can make it from grasses with more trouble. And yeah, we do have one kind of blue-green algae that just makes it. Some people have described it as it's kind of like livestock. It's a no-kill process. We don't kill the blue-green algae. They just produce, like livestock, they produce the fuel. So you can do that. But if you don't want ethanol, and maybe you don't want ethanol because you cannot fly an airplane on ethanol, maybe you want like kerosene, jet
Mm.
fuel.
Mm.
So then you would have probably a different thing you're growing. It could be a blue-green algae, but you might be going for just making as much algae mass as you can. Some of it has oils in it, and then it is a harvesting process. You are taking the algae. So then you're taking the algae, you're taking it out of there, and then getting the oils out, and you're making what's called a bio-crude from your biomass material. You're making your bio-crude, then with some upgrading, the little secret sauce that isn't completely wonderful yet, you send it to a petroleum refinery, just like crude oil, and then you can get, your jet fuel, your diesel, your gasoline, your naphtha out of there. So there are a variety of options, you know. We won't be without fuels even if we are without petroleum.
Great. At what cost? As in, if you were to look at it, you're in the US, so we'll say a gallon of kerosene today versus a gallon of bio-kerosene, we'll call it.
Yeah.
How do they compare price-wise?
Okay. So I am not speaking for any company, and I am hoping I am wrong. But, you're doing really good if you can make an aviation fuel, a bio aviation fuel for $5 a gallon. We have to do the conversion to liters. So that's north, and then I'm talking in dollars too. I apologize to everyone listening internationally. So let me just stick with $5 a gallon. It might be something like €2 a liter. And that would be good. I have seen numbers, definitely seen numbers because I have calculated them personally myself. $8 to $10, it could be that. So it's not a good number.
Mhm.
So it's not what the aviation industry, for example, wants to see. That is, getting off on sort of another topic, that is a reason that there isn't a lot of what's called sustainable aviation fuel available.
Mm.
One is, even our local airport, Atlanta, Hartsfield-Jackson International Airport, the busiest airport in the world, they need 1 billion gallons a year. So to have a drop in the bucket is a very big bucket. But also, it is expensive.
Mm.
So the attractiveness is nuanced.
Sure. And I mean, we've seen the price of solar, drop over 99% in the last decade, and similar for wind, not quite 99%, but 80% in wind, and battery storage, again, similar numbers there. But those are processes that are quite easy to scale up and therefore drop the price. Would the same kind of learning curve apply to the production of biofuels?
It's it's great. And you can say now in retrospect, oh, that was easy. They were just well set up for scaling. A decade ago, people didn't know that. It's really hard to know what technologies can scale. They don't all work. Nuclear has not worked well.
Hmm.
Biofuels have not worked well, but there are different kinds of biofuels. Manufacturing something it's been in the manufacturing where prices have really dropped. And then there are some other obvious things. Like if you can get a cheap feedstock, then your product is going to be less expensive than if you have an expensive feedstock. So, if we can make algae really cheaply, I mean, it should be really cheap. They just grow all over people's ponds. That's a way to go. But getting the production down and scaling it by having a lot of them, yes, it brings costs down. And another thing to look at is not just bringing the production costs down, but can we make several products? That's what petroleum refineries do. In
Mhm.
fact, sort of the secret is that's how they make their money. They do not make their money on gasoline or even gasoline and diesel. Well, okay, they're making a lot of gasoline, a lot of diesel, a lot of jet fuel, and chemical feedstocks. And it's on these chemical feedstocks that you put your whole business together and it works great. So that's kind of the idea with we want to capture carbon dioxide from the air, make fuels, make chemicals in a kind of biorefinery, and with multiple efforts, bring the cost down, have multiple products, refine what you're doing, build a lot out. Possibly there could be success.
Okay. Interesting. Interesting. I gotta wonder, the fossil fuel companies that are out there today, their reputations have been destroyed by what they've done knowingly to the planet. If this is possible, why wouldn't one of them try and take it on so that they could try and in some way salvage what's left of their reputations
Mhm.
and utilize the refineries that they already have in place so they could do it, you know, lower cost than anyone else.
Yes. Well, there are major companies that are investigating exactly this. Like we have our huge infrastructure for making fuels and chemicals. Can we just get a different feedstock? And so, yes, there's active work on that, both for getting. So, it's do you get your carbon dioxide from the air kind of mechanically through direct air capture? Do you get your carbon from plants, but just get a different feedstock and then shoot it into this already cost reduced infrastructure we have for making fuel? So there's a lot of work on that.
Okay, good.
And it's kind of hard. So there've been efforts that have not come to fruition yet. Exactly, they're working on that.
Super, super. And what about other alternatives like growing trees and building with mass timber, which are kind of natural ways to capture carbon? How do they compare to the high tech approaches like direct air capture in terms of scalability and effectiveness?
Okay. Effectiveness, growing trees works. We know how to do it, and we don't even have to do it. We just have to let the tree grow. The tree sucks in carbon dioxide from the atmosphere, from the air, and it becomes the tree.
Mhm.
So it's a fabulous solution. Will, just taking the earth as a whole, will we have more trees, more tree mass on the planet? How can we ensure that? How can we make sure that, if a forest products company says, here, we're growing trees, we're sequestering carbon, okay, but they're cutting down the other trees here. So the challenge of growing more trees is we need to get it, just like with all these other solutions, up to scale. There's some great ideas, like even in pasture. And if if your listeners have pasture, consider growing more trees in your pasture. Your
Mhm.
livestock may enjoy it. You'll capture some carbon, but that's 1 or 20 trees. So it's a great option. It's it's scalable, and you can even have successful forest products in a situation of having more standing biomass. You can harvest the trees repeatedly. And then, as you mentioned, there are some uses of trees by people that pretty quickly put the carbon back in the atmosphere. The most obvious one is burning. That's what many people worldwide use for cooking. They burn the tree and it puts the carbon back in the atmosphere, but then the trees regrow. It's kind of a closed cycle.
Indeed.
However, another thing that also humans have been doing for thousands of years is use trees to build our houses. You can use trees to build other things like furniture, but the houses and the buildings, they have a lot of mass in them. And if that's wood, your building is sequestering carbon.
Yeah.
So, one of the things that we've looked at recently, in fact, in the state of Georgia, where we have a lot of forest and elsewhere, is can we use more wood in making buildings? Not only relatively small buildings, houses, but big buildings, office buildings. And we can.
Mhm.
And there are two benefits to that. One is, yeah, you've grown your tree. You Sometimes it's cross laminated timber is used to make it really strong as a building material. So then you're keeping carbon in that building for the life of the building, and even sometimes afterwards, sometimes that material can be reused in another building. So you've got carbon in your building. That's how we're getting carbon out of the atmosphere. We're putting it in our building. And another benefit is that your wood there is substituting for steel.
Right.
There are a lot of emissions of carbon dioxide in making steel. So much less than growing a tree and even making the cross laminated timber. So you've got two benefits. And well, I'll just advocate for something. We should do more of that. We can have more wood material in buildings as a really long lasting way of saving the good work that the trees have done.
Okay. And again, with using wood in buildings, how well does that scale? And if I'm asking that, what I mean by that is, you mentioned yourself, it's fine for smaller buildings like households, but you mentioned office buildings. Are we talking 2, 3 story office buildings, or can it go much taller? How much can we really substitute wood into larger buildings?
Okay. So here I am slightly beyond my knowledge. I do not know what is the maximum size of a building that could be mass timber, but there are, 8 story buildings, multiple ones. We have really nice buildings down in Ponce City Market in Atlanta, mass timber. So these are big commercial scale buildings.
Okay, cool, cool, fine. Quick kind of left field question.
Great.
If we were to fast forward 50 years into the future, what do you think would surprise people the most about how we solved or failed to solve our current climate crisis? Where do you see the biggest breakthroughs coming from?
Okay. I was surprised when solar got so cheap. I was surprised when we figured out how to do fracking of oil and natural gas so cheap, actually. I was surprised by batteries being cheap and wind being cheap. So, one is we're going to be surprised by something else. I don't have the prediction of what that is. But the other thing I think will surprise us, because it's more obvious to me, is that there will be changes in what people do. We get kind of fixed on thinking, okay, the way I do it now, first of all, is probably the best. It's the best way. And then, even if it isn't the best way, how could I possibly do something differently given my life and my kids and everything that's happening and the need for people to drive into their jobs? So I think we're going to be surprised that some people will start doing some things that we're really surprised that they do, um, that will be cheap and will just solve, like, let's go for it, a third of the climate problem will be solved by just a different cool way that people want to go about what they're doing that isn't emitting a lot of carbon.
Okay, super, great, good to hear. We are coming towards the end of the podcast now, Valerie. Is there any question I did not ask that you wish I did, or any aspect of this we haven't touched on that you think it's important to make people aware of?
Well, all right. I work on hard problems. I'm a researcher.
Mm.
That's what I do. I work on problems, on things that seem like they're really not going to work. Like, Valerie, why are you working on that? It's so stupid. But, I work on these things to try to make them better. I do want to underscore that through working on these really hard things, it's made me so much more receptive to just simple stuff. Like, rather than we do need to build this huge machinery and capture carbon dioxide from the air and pop it off and try to make biofuels. And we're really making sludge and we've got to make our fuel out of sludge. Just, just go ahead and, for instance, just in complete frustration, I take the bus, and taking the bus is really fun to do. I learn more about my neighborhood and where the buses are. So there are all these technical solutions work, um, but there's a whole bunch of choices. So I'd like to just point out to people, you could do some of them and save some money or get some more exercise, do something like that. It's not that bad.
Yes. Okay, great. Super. Valerie, if people would like to know more about yourself or any of the things we discussed on the podcast today, where would you have me direct them?
So I'm at Georgia Tech, and so they can find my website there.
Great. Super. Shoot me across the link and I'll include it in the show
Yeah.
notes so everyone has access to it. Great. Valerie, that's been really interesting. Thanks a million for coming on the podcast today.
Thank you. This was really fun.
Good.